and said objects are the way to go. So objects were going to kill the relational database. Now, cloud databases are going to kill the relational database. Key value stores, also known as KVS databases, are going to kill the relational database. It's not true in any way, shape, or form. If you look at a key value store database, names and values, they work very well for certain types of applications. I'm on Amazon.com, and I'm shopping. A key value store works very well for your shopping cart on Amazon. They don't know exactly what you're going to put in the shopping cart, how many things you're going to put in the shopping cart. They need a very generic data structure. So the shopping cart works very well with the KVS. It works very well because they don't know the data structure, so the developers like it. It also works well because of the way they query the key value store. On Amazon.com, they never ask questions like, how many shopping carts have red shoes in them? They don't do business analytics on shopping cart data. The way they use the shopping cart is, Tom's shopping cart, what's in it? That's the only way they query it. They don't ask questions across shopping carts, so yeah, they can break the data up and store it in a million little places. As long as they can find my shopping cart, this works well. But if you need to ask the question, how many shopping carts 2 days ago had blue shoes or yellow books in it? That's like a business analytic function, something you might ask in your data warehouse. That doesn't work so well in the key value store. It works very well in the relational model. On Amazon.com, when you check out, they don't store your order in a key value store database. They turn it into rows and columns in an order fulfillment system. And all of a sudden, the real data processing is taking place on structured data. We need both of these databases. There's an application development environment called Application Express, Apex. It's built in PL SQL. It's what I use to build AskTom with. At the heart of Apex is a table that has session ID, name, and value. At the heart of Apex is a key value store inside the Oracle database. We use it to maintain session state. It works very well for maintaining session state. So AskTom uses a key value store, but not to store the questions and answers, not to store the audit trail, only to store the session state, because it makes sense. I don't know what my session state attributes are. If somebody adds a new stream, I have more session state that I'm going to manage. I can't create a database table to hold this, so we use the key value store. But as I go from screen to screen, and I query data, or I store data forever, those are in rows and columns. We're going to need both types of databases. It's not either or. It's sometimes one is right, and sometimes the other is right. And then the last questions as we close out. So you're telling me to do more? Okay. We have other questions. We were worried about running out of time, so I'll go back and hit those. See, I know the translators are back there going, oh good, he's going to pull up a lot of slides that we haven't seen yet. So here was one. It's talking about the in-memory database cache, times 10. This is a good example of Oracle getting a technology and integrating it in with the database. You have this in-memory database cache, times 10. You can use it to accelerate OLTP systems, or can we use it to accelerate our OLTP systems? Can we just turn this on and make things go faster? What are the things we should consider when using the in-memory database cache? What should we be looking for that tells us we might need to use this new capability. What the in-memory database is good at doing is giving you guaranteed response times on queries. Normally, if I submit a SQL query to the database, select star from end, or end equals 1, 2, 3, 4, you have no idea how long that query is going to take from execution to execution. One time you run it, you might find all of the index data in the buffer cache, all of the table data in the buffer cache, and the network might be very free and clear, open. And you get the answer back in 1/1000th of a second. The very next time you run that same query for the same exact data, one of the index blocks got bumped out of the buffer cache, one of the table blocks got bumped out of the buffer cache, and somebody started downloading a large file. Now all of a sudden the network round trip back and forth takes longer than it did the last time, and the query takes 100 times longer to run because it's doing physical IOs, not just reads out of the buffer cache. So instead of taking 1/1000th of a second, it takes 100th of a second, or 1/10th of a second. It's running a lot slower than it used to. And in reality, a performance graph might look something like this. The query response time for a relational database would fall into the red category. Sometimes it runs really, really fast. Sometimes it runs really, really slow. There's a lot of latencies involved. And I can't guarantee you a response time. In-memory databases remove the latencies due to disk, and if you put the in-memory database right next to your application, the network. And all of a sudden you get a response time that looks like the blue line. It varies a little bit, but by very little. It's more of a flat line. It's based on how many CPU cycles does it take to execute this query. So if you're thinking about using the in-memory database, this graph should pop into your mind. You're going to change the red line into the blue line. Now notice, the red line and the blue line intersect sometimes. Many times, the relational database is as fast as the in-memory database. But what you don't see are the wide variations in the runtimes. So if this is something that is causing a problem in your application, the latencies, the wildly different response times, then you should consider looking at the in-memory option to the database. One thing we've done in 11G with times 10 is to make the SQL in times 10 compatible with the SQL in Oracle. So you can take an application that was written against Oracle and put it on times 10, and the SQL capabilities are there. We implemented all the same data types in times 10. So times 10 has the Oracle number type. It has varchar2 in it. It has all the data types that you would use in the Oracle database. The other thing we've done with IMDb recently is we implemented PL SQL in IMDb. It's not 100% implementation. It's most of PL SQL. So I should be able to take most of my stored procedures and drop them into IMDb without having to change them as well. The third thing we did was we made the interface to IMDb become OCI, our call interface, our Oracle call interface to the database. This is our C-level API, upon which JDBC is built, ODBC is built, ODP.NET, PHP drivers, Ruby drivers, and so on. So all of the major APIs are built on top of OCI. You can take those applications that were running against an Oracle database one day and just repoint them by changing the TNS connect string to a times 10 database. And for the most part, they should be able to run unchanged. We even moved over major features like multi-versioning and